So if we look at the evolution of artificial intelligence systems, we have to start from the very beginning. So the beginning was the phase one, and it was rule-based systems. So the year 1950s to 1990s, like whatever systems we had, we used to call it like expert systems also. They were rule-based systems. So the idea was, in those rule-based systems, there was explicit if-then logic. And the idea was we have to write the logic. Rule-based system is we have to feed the loops. Expert systems, we have to feed the loops. Logic, we have to feed the logic. We have to write the logic. And based on that logic, the system will take input and it will generate an output. So it was very deterministic, because it was very much understood that, okay, this is the logic. If this is the input, this has to be the output. Deterministic means we can easily predict the output of the system. Given the input, we can predict, okay, if this is the input, this will be the output. So the rule based system, they were deterministic in nature, and they were brittle and non adaptive, meaning to say that if there is some ambiguity in the input, then the system will fail. And system, like, it is pre-programmed because the logic is fed. Now with time, if the concepts are evolving, if the logic is changing, system cannot adapt, because whatever is pre-written logic, system will behave according to that. And hence this system is non-adaptive and it is brittle means if some uncertainty in the real world or in the input, the system will break. It will not be able to adapt. That's the idea. So the example of a rule-based system is, let us suppose there is a logic that, okay, if the temperature is greater than 100, then shut down the machine. Now the limitations, as we saw, like the limitations of rule-based systems, rules explode combinatorially, because if I am writing all the rules, may explode, because it might keep on increasing. Because if I am making a expert system for a particular healthcare segment, the rules might keep on exploding. Rule-based systems cannot handle ambiguity. They cannot handle ambiguity, and they fail outside predefined scenarios. Rule-based systems, they fail outside predefined scenarios. Because that's very clear that, okay, whatever logic we have fed, we have written, the system will behave accordingly. If something happens outside that logic, system will fail. So the rule-based system will fail outside predefined scenarios. That's the idea. Now the next is the traditional machine learning system, the phase two, because we are talking about the evolution of artificial intelligence systems. We started with the phase one, that is the rule-based systems. Now we are moving towards traditional machine learning systems, that is 1990s to 2015. Now in machine learning, the idea was we used to supply huge amount of data to an algorithm which can learn patterns in that data. So we call it like the training data. So machine learning systems are statistical models trained on data. Statistical models trained on data. So machine learning is based on pattern recognition. Machine learning systems can recognize patterns in the training data, and it is mainly focused on predicting something, either predicting a value or a real number, or predicting any class label, or predicting trends based on the time series data, or predicting weights or the priorities for recommendation systems. So machine learning systems are prediction, like they are basically predicting. They are based on pattern recognition, wherein they recognize patterns from the training data. Now the capabilities of machine learning systems, they can classification. Classification means whatever input, they will label it. Okay, this input belongs to class A, this input belongs to class B. Regression. Regression is predicting a real number. Recommendation. Recommendation means, like, based on several options, it will pick two, three most suitable options. So it will recommend. those things to the user. And forecasting means based on the time series data, we'll be predicting some trends. So all these are the capabilities of machine learning systems. So machine learning systems, the good thing about it is that it is adaptive to a certain extent, because if some ambiguity is there in the input, then also it will be able to handle it, because machine learning can handle uncertainty. Machine learning systems are designed in such a way to handle uncertainty. Some ambiguity in the input, machine learning systems can give us a reasonable output. It can handle those ambiguities. So we can say that machine learning system is adaptive to a certain extent. That's a very big evolution actually, because in machine learning system the good thing is that no need for you to write the rules. Because see, what is artificial intelligence? Artificial intelligence means algorithm on its own should devise a way to solve a problem. If we tell algorithm how to solve a problem, then it is human intelligence. Then though algorithm will just be a dumb. It will just follow our instructions. How it can be intelligent? For it to be intelligent, we will tell our requirement, okay, we want to achieve this, and algorithm will on its own identify a way or solve a problem to get us the result. That is artificial intelligence. So the rule-based systems, we cannot say to be truly artificially intelligent, because there we have to tell the way of solving a problem. That was a very big drawback. But in machine learning, the good thing is that we don't know how to solve a problem. We just tell machine learning systems, machine learning algorithms that, okay, see, this is the input and this is the output which I want. So for this input, this will be the output. For this input, this will be the output. And we give millions of training data, wherein input output mapping we give. And algorithm will on its own recognize the pattern that, okay, if this is the input, this has to be the output. If this is the input, this has to be the output. It will learn the pattern on its own. We never tell it the way to learn the pattern. So since it is learning the pattern on its own, and when you give it a test input, it will figure out the output on its own based on the pattern recognition which it did. Hence, it is truly an artificially intelligent system. So machine learning is truly artificially intelligent system. Now the limitations of machine learning, see, we already saw that machine learning systems, they predict, but they do not act. Meaning to say that they can do some predictions, but they cannot perform any action. They will just give the output to the user and user have to take the decision. So machine learning systems, they do not plan. They do not reason across steps. They do not decide what to do next. So they don't have the power to act. So machine learning systems, we can say it to be very passive in nature. They're passive. They cannot plan. They cannot reason. So what is plan? Plan means, okay, I want to achieve an objective or a goal. So step by step, okay, I have to do this step 1, step 2, step 3, step 4. So plan means to achieve a objective, a goal. I'll figure out some steps of execution. Then every step, the reasoning capability, like, okay, to perform this step, what actions I like, how I can accomplish or how I can execute this step. So reasoning, and what decide what to do next. Okay, this step accomplished, or there was some problem, then what is the alternative way? All that. So this kind of a intelligence is missing in machine learning systems. Okay, now we are discussing the phase 3. Phase 3 was deep learning and foundational models. That is 2016 to 2022, especially the transformer architecture and all that. So deep learning and foundational models. Now what it was, see, deep learning is like neural networks. Deep learning is like a deep neural networks at scale. Now the very good thing about deep learning was, like if we use like a deep neural network, it has a very interesting property of representation learning. Now, what is this representation learning? Representation learning means like whatever natural language we have, the text and all that, we can convert it into a vector space, and there similar words or similar context, they are aligned in a similar manner. So we call it representation learning, wherein uh, text, we convert it into a vector space, we represent it in the form of vectors, and there we learn patterns. And because of this representation learning, deep learning got a special capability, special ability to understand general purpose language like English, French, Spanish, any general purpose language you take, deep learning can understand it, because the language we are converting into a vector space, and there we are doing the representation and we are learning the patterns out of it. So this made this deep learning very powerful, and it was a very big breakthrough, because now models, they started understanding instructions. Because earlier machine learning, input output, you have to give a input to be a data a- and output, but now you can give instructions to the deep learning, and AI systems can understand the instructions. So models can understand instructions because of this breakthrough in deep learning and foundation models. Models can generate reasoning like outputs. Now the output of the model will not be just a label or a number or a recommendation or a forecast, but rather it will be a text. It will be more of like a human response. We call it reasoning like outputs. And model can generalize across domains. The idea is that, see, machine learning, the drawback is it is very specific. It is specialized for one task. Like if you train a machine learning model, it is specialized for that particular task. But deep learning and these foundation models, the good thing about that is they have uh, some sort of generalization. They can generalize across domain. It means they have multiple capabilities. It is not like, okay, they can perform only one action. They can perform different set of actions. So that's the breakthrough. Deep learning and foundation models, they can understand instructions, they can generate reasoning like outputs, and they can generalize across domains. Now, what is still missing? Now, definitely, we are seeing the evolution. Okay, so before going to that, let us feel the evolution. So, we saw how the artificial intelligence systems, they evolved. We started with rule based systems, which was not at all truly artificially intelligent, also because we had to tell, we had to write the logic to solve a problem. So, we are feeding the solution, the way to solve a problem. Then in machine learning, the good thing was we are just giving it an idea about the input and the output, and algorithm on its own is devising the solution. And since it is devising the solution on its own, it is applying its intelligence to solve a problem, because here the problem is solved by the algorithm itself. We are not at all telling how to solve the problem. So that's why machine learning is truly artificially intelligent. But the problem was machine learning was, it was highly specific in nature, and they cannot act, they can just predict. Then we got deep learning. The good thing about deep learning was it became a sort of generalized. It can perform multiple actions, and also it started, it became more intelligent, wherein it started understanding natural languages, it started understanding instructions, and it started generating some reasoning like outputs. So some very good capabilities we got. So here now, uh, the deep learning and the foundation model, and we will call it large language models. So LLMs, the good thing is that they can reason, they can plan. LLMs can plan, they can reason, they can also decide. But LLMs are also, they cannot act. Now the drawback of this deep learning and foundation models, and I am calling it LLMs, large language models, the limitations are persistent goals. The persistent goal is missing. They are stateless. Stateless means, okay, you are giving the input, it will give the output, and it will forget. So it will not it does not have the capability to stick with the goal. So persistent goals is missing, memory component is missing, autonomy is missing. Autonomy means it cannot act on its own. It is dependent on the user. Whatever user will tell, it will just act on it. So autonomy is missing, and execution loops are missing. Like large language models, they cannot execute instructions or execute tasks. That was the missing point. But large language models, they are very smart in that sense that they can plan, they can reason, they can decide what to do next. They can do all this, but they cannot act. And now we are in the phase 4, autonomous agents. And that is what this course is about, autonomous agents. So until now, the AI was very passive. Passive in that sense that, okay, whatever you tell it to do, it will do. Definitely, it will do on its own. You will just tell the AI that, okay, I want this. It will give you the way. Okay, you want this. This is the strategy for that. So it was very passive. But now, autonomous agents, they will go one step ahead. They became active. Now they will not just recommend or tell you the strategy, rather they will execute the strategy on your behalf. So agents, what they can do is that they can decide what to plan, what to do. They can plan actions. They can even make use of tools. So agents, they can on their own autonomy, they can call the tools and perform some data processing, and the result, they can make use of it. They can monitor outcomes, they can adapt over time. So that is the idea, evolution of artificial intelligence systems. So now this is the era wherein there is a complete transformation, and from 2022 we started talking about autonomous agents. So this is a complete transformation. So this is the evolution of artificial intelligence systems.